myself Pankil Shah. You are studying subject Basic Electrical Engineering, and in this subject you have seen some videos of the chapter AC circuit. We have analyzed a different type of circuit. We have analyzed the pure resistive circuit, pure inductive circuit, pure capacitive circuit, series RL circuit, series RC circuit. So in series RL and series RC circuit, you have heard some terms, and that terms are impedance Z. We have not discussed what is impedance Z, what is vector diagram, what is voltage triangle, power triangle, what are the different type of powers. So that concept will be covered in this video in case of series RL as well as series RC circuit. So let's first begin with the series RL circuit. So let's recall the vector diagram of series RL circuit. So this is the vector diagram of series RL circuit. In series RL circuit, if we have taken current as a reference, so if we are taking current as a reference, then VR will be in the same phase. VL will be leading from this current I by 90 degree. So VL will be 90 degree from the current, and VR will be on the same phase as the current. And if we joining these two voltages by the parallelogram method, then we obtain the diagonal of this parallelogram as the resultant voltage V. And this resultant voltage V was making 5 degree angle with the resultant current. And this current is behind this resultant voltage, so we can say that the current is lagging behind the voltage. This already we have seen in the previous video of the series RL circuit. So let's talk about the first triangle, that is the voltage triangle. So we have seen the vector diagram of series RL circuit. So from that vector diagram, we are only taking the voltages. So on the reference axis, it will be the voltage across the resistor, that is VR. 90 degree from that VR, there was the voltage across the inductor, that is VL. And if we are joining these two voltages, then there was a diagonal and it was the resultant voltage V. So now what is the equation of the voltage across the resistance? And the equation of VR is I into R, where I is the RMS value of the current flowing through that series RL circuit, and it will be the same. Value of this VL is nothing but the inductive drop across the inductor, and VL is equals to I into XL, where XL is the inductive reactance. And the joining element, that was the resultant voltage, is having the equation as V is equals to I into Z, where Z is the impedance of this circuit. So if we apply Pythagoras theorem to this triangle, then we obtain the equation as the resultant voltage V is equals to under root VR square plus VL square. If we put the value of the VR and VL in this equation, then it will be under root IR whole square plus IXL whole square. So I square will be making common from this equation, and if we are taking I square outside that square root, then it will be I. So V is equals to I, in bracket it will be R square plus XL square, and this R square plus XL square is nothing but the Z, and this Z is nothing but the impedance of your circuit. So this is nothing but the voltage triangle of series RL circuit. So now next is the impedance triangle. If we divide each side of this voltage triangle by I, then we get the impedance triangle. So here it was IR. So if we divide this side, reference side by I, then it will be R on. Here it was IXL. If we divide that side by I, then it will be XL on. And this diagonal, if divided by I, then it will be Z on. So if we apply Pythagoras to this impedance triangle, then it will be Z is equals to under root R square plus XL square, where Z is the impedance, R is the resistance, and XL is the inductive reactance. And the angle phi between these two axes, that is the Z and R, is the angle phi. And if you want to find the phase angle phi, then the equation will be phi is equals to tan inverse XL by R. Or you can find the phi as cos inverse R by Z. So now let's see the power triangle. So if you want to find the power triangle, then you have to multiply each side of voltage triangle by I. So if we are multiplying the x-axis by I, then it will be I into VR, or you can say VR into I. This side is already VL, so I into VL will be this side, and the diagonal will be capital V, so it will be IV. So this is known as the power triangle. So the power is having two components, we can say. This power is making 5 degree with this x-axis, so the total power P is equals to VI, and this total power is making two components, that is one cos component and one is the sine component. So the cos component of total power is given as our real power, or you can say the active power. So active power is given by P and its equation is given by this is VI. So its component is VI cos phi. So the answer of active power P is equals to VI cos phi, and it is measured in watts or kilowatts. So what is reactive power? So reactive power is given as the sine component of this total power. So this total power in diagonal VI is making two components. One component is cos phi. So VI cos phi is the active power, and this VI is having another component at 90 degree, and this component is known as the reactive component of this power. And this power is given by the reactive power Q is equals to VI sin phi, and its unit is VAR. V is the unit of voltage, that is volts, A is the unit of current, ampere, and R represents this is the reactive power. So VAR is the unit of the reactive power. Now finally our total power, that is the apparent power, is represented by this diagonal, and it is S. S is equals to apparent power, and its equation is V into I, where V is the total value of the RMS voltage, total value of the current, RMS value of the current as I. So this S is equals to VI is the apparent, or you can say the total power, and the unit of this apparent power will be VA. Sometimes it is measured in kV. So this was all about the series RL circuit. Now let's define this three type of power. So the first power is nothing but the active. So the active power is the total power consumed by. Active power is the total power consumed by the circuit, which is consumed actually, and it is given, and it is due to the resistive part of your circuit. If only resistive part is there, then the total power will be consumed by the resistor only. If pure inductor and pure capacitor is there, no resistor is available, then no power is consumed as actively. So if RL or RC combination is there, then we can say that the total power consumed by circuit is only due to the resistor, and it is known as the active power, and its equation is P is equals to VI cos phi, and its unit is watts. Next power is known as the reactive power. So reactive power is the power drawn by the circuit due to the inductive or capacitive components connected in that circuit. So if we are talking about the pure resistive circuit, then the reactive power will be 0, because no inductor and no capacitor is there. If we are talking about the pure capacitor and pure inductor, then the total power consumed by that circuit will be the reactive power. No active power or the real power will be consumed. But in case of RL and RC circuit, there will be reactive power also. And this reactive power is given by the equation Q is equals to VI sin phi. And the unit of this reactive power is nothing but the VAR or kVAR. Now, the total power. So the total power in any circuit is given by the formula S is equals to VI. This is the total power actually given to that circuit. So S is our total apparent power is equals to V into I, and its unit is V into A, or sometimes it is measured in kV. So this was all about the powers. Now let's talk about series RC circuit. So in case of series RC circuit, we have seen this phasor diagram, but first let's recall this phasor diagram, as we have taken current as a reference. Voltage was written on the same phase as current, so it will be VR. VC will be lagging behind the current by 90 degree. If we join these two sides by parallelogram method, then this diagonal represents the resultant voltage V, and this V is making some angle phi with current I. And you can see that current I is leading from this voltage by 5 degree. Now let's understand different type of triangle in case of series RC circuit. So the different type of triangles will be again the same: voltage triangle, impedance triangle, and the power triangle in case of series RC circuit. So if you want to draw the voltage diagram or the voltage triangle in case of series RC circuit, then again you have to only take the voltage from the phasor diagram. So on the x-axis, or you can say on the reference, it was VR, because it was the in phase with the current. We are neglecting the current, only taking the voltages. So VR will be here. On the 90 degree below that VR, it will be VC. It was the capacitor voltage VC. And if we are joining these two vectors, then it will be the voltage total voltage V. Let's put the equation of these three voltages as VR is equals to IR, VC is equals to I into XC, and V is equals to I into Z, where Z is the impedance of that series RC circuit. So if we are applying Pythagoras to this voltage triangle, then it will be V is equals to under root VR square plus VC square. If we are putting the values of VR and VC in this equation, then it will be under root IR square plus IX square. So I square can be made common from these two terms, then it will be under root I square in bracket, it will be R square plus X square. If we are taking I square outside the square root, then it will be V is equals to I under root R square plus X square. So this under root R square plus X square is known as the impedance of this circuit. So Z is equals to under root R square plus X square. So we can say that we have the equation from voltage triangle as V is equals to IZ, where Z in case of RC circuit is equals to R square plus X square, where Z is impedance of this circuit, R is resistance of this circuit, and X is the capacitive reactance of this circuit. So now let's move towards the another triangle, and another triangle is nothing but the impedance triangle. To draw the impedance triangle, we have to divide each side of the voltage triangle by I. So if we divide this first side IR divided by I, then it will be R only. If we are dividing this side by I, then IXC by I, it will be XC only. And if we are dividing diagonal by I, then IZ by I, so it will be Z only. So now we have three components, R, XC and Z. So if we are applying Pythagoras theorem to this, then it will be Z is equals to under root R square plus X square. We obtain the same equation as we have obtained in the voltage triangle. And if you are measuring the angle phi between the diagonal and our reference, then the angle phi is given by this formula tan inverse XC by R. And this phi is nothing but the angle between voltage and current. If you want to find the power factor cos phi, then it will be R by Z, because cos phi is equals to adjacent side to the hypotenuse. So it will be R by Z. Now let's talk about the third triangle, and third triangle is nothing but the power triangle. So to draw the power triangle, we have to multiply each side of voltage triangle by I. So if we are multiplying VR with I, then it will be I into VR. If we are multiplying VC by I, then it will be IVC. And if we are multiplying our diagonal V with I, then it will be VI. So this VI is known as the apparent power. So the component of this apparent power is, this apparent power is making phi angle with the reference. So this reference is known as the active power, cos component of the total power, and it is given by the equation P is equals to VI cos phi, just similar in case of the RL circuit. So active power P is equals to VI cos phi, and unit is watts. This total power is having another component at 90 degree, and this component is the sine component, and this is known as the reactive power. So this reactive power is given by the formula Q is equals to VI sin phi, and it is measured in VER. And the third power is the diagonal, and it is nothing but the total, or you can say the apparent power, and it is given by the formula S is equals to VI, where S is the total apparent power, V is the RMS value of the voltage, and I is the RMS value of the current. So in this way, you can define these three parts. But you can see that this Vi is the total power and phi is the angle between voltage and current. So in case of active power, it is Vi cos phi. And in any type of electric circuit, active power plays the major role. So this cos phi is the deciding factor that how much of power will be consumed actively from the total power. For example, cos phi is having the value between -1 to 1. But if we are talking about only the positive value, then cos phi is having the value 0 to 1. So whatever the voltage or whatever the current is, if cos phi is 0, means if power factor is 0, then no power will be consumed actively. So that means cos phi is the important factor. If cos phi is 1, unity, then the total applied power Vi is used as the active power. No reactive power is there. So that means this cos phi plays the important role in any type of AC circuit. So this cos phi is known as power factor of any type of circuit. So thanks for watching this video. Stay tuned.